Frazee again, and this is the S60-139 CAM or drive post tutorial. So we're going to mill another steel part here. It's mild steel. It's a multiple setup part. There's a variety of ways you could approach this. A traditional machinist might machine both ends off square first and do a lot of the work in vise operations. What we're going to do is we're going to assume that we're making custom fixturing for this and maybe make some accommodation for clamping spaces, but we'll get into that into the fixture building class. We want to focus on learning how to use the CAM routines. So the method I will have you go through is a viable method to make this part, but there are different ways to approach this. Okay, so we're gonna, without further ado, we're going to move on. Okay, so we've got our part, and we're starting off with bar stock. That's roughly the same profile as the footprint. I believe it's 1/2 inch by 2 inch, and it should be pretty close to our overall width here. We have 2 close diameter dowel pin holes and a threaded fastener hole in the center, which is a 632. Those are the same scheme as we used in the plate that this mounts to. We've got a loose tolerance 1/4 inch hole here, which we'll drill, and then we have a tight tolerance bore here, which we're going to approach carefully. And then we have you should have a 30-second round going around the outside edge here, going around, and we're going to use a corner rounding end mill to achieve that. So I think the minimum number of setups for this part is 3, and so let's go ahead and create our 3 setups. Okay, so we've got our first setup is going to be roughly in the position that we are now. So bar stock, perhaps on a vise with the right hand end sticking off the edge of the vise so that we can mill that face nice and square, okay, to all the other features. All right, so we're gonna highlight our operations. We're gonna create a job, and that job is going to be the S60-139 OP1. And we're going to use a relative size box, and we are going to use some extra material. So our additional stock, we're going to select all sides, but we're really only going to add it in the x-axis. Actually, we're going to set our origin first. So we're going to do z-axis and y-axis. We don't really have a good x-axis reference other than these holes. Okay, so our z-axis is going to be the face of the part, and then our y-axis we're going to set as a vertical edge on the part. Okay, and so we get our trihedron where it's supposed to be, with x pointing to the right, y pointing away from us, and z pointing straight up in the orientation of the spindle. We're going to use a stock box point, and we're going to use the bottom corner 3, okay, and it puts it at the bottom of the part. Now the reason I do that is if your stock varies in size, your origin's never moving. It's at the bottom of the parallel. A lot of traditional machinists are used to using the top of the material because they qualify the top of the material first with a face mill. But I found that this method works pretty well for me, but you would set your Z height origin at the top of the parallels or the bottom of your part, and whether your stock varies or not in height, well, you don't have to do any adjustments on the machine. Okay, so scrolling back to our stock, it's a bar stock. The width 2 by 3, I believe. I'm sorry, 1/2 by 2. But we're going to extend the ends as if we would cut this on a bandsaw, and it's rough stock. Sorry, 30 thousandths. So a total of 60 thou. Okay, so that represents our stock with a little bit of margin on either end. Okay, and then our program name is pretty much going to be the same as what we had up here. Or, I'm sorry, our program comment. Program name is going to be 139 139, the first program. And then we'll go ahead and hit accept on that. Now let's change our job folder to S60-139 Op1. Let's go ahead and start programming this. And for our Op1, if we're holding this in its rectangular stock like we have shown, it's held in a vise, perhaps we hold on to the first quarter or eighth inch of material. We don't want to cut all the way down to the vise, so we're running the jaws around the profile. So what I suggest we do is we have the end hanging off. We can cut that face all the way down to the end, which will make it square and parallel. And then on our second side, we don't need to machine that edge. In fact, that edge could be used as a datum. Okay, and then we have our hole. And then we have our counter bore on the one side. Now the counter bore is very precise, so we could use that for location when we flip the part. Yeah, I suggest we do that. Okay, so what we're going to do is we're going to cut, first we're going to cut the hole that goes all the way through. So we're going to do a spot drill, then we're going to do a 1/4 inch drill, and then we're going to come back with an end mill to make the pocket. And then the next step is we'll use that same end mill to run partially around the profile in depth and then machine off the side face of the part, so that's qualified. And so in that setup we'll be establishing the distance between this face and the center of the hole feature in one setup, which is more accurate than if we do that in multiple setups. Okay, so now what we're going to do is let's start, like I said, with the hole. So we're going to go to drilling, and we're going to do a drilling operation. And from our library, we're going to grab our spot drill, tool number 6. Okay, and again, we're cutting steel, so we're going to slow our RPM down. And we're going to go to 10 inches a minute on everything. So we're going to go nice and slow with this cutter so that it doesn't flex, doesn't break the tip on it. Okay, we're going to go into the next step. And what are we drilling? Why don't we just select the chamfer? That's enough for the spot drill. We're going to go on to the next step. We'll leave all our heights at default, but we're going to go from the top of the hole and then our reference for the depth is going to be the top of the hole as well. And we're going to measure, go to evaluate, and we're going to measure that diameter of that chamfer, and it's 400 thousandths. I'm just going to go and increase my significant units just to make sure. Okay, it's 395 thousandths, so we want to go half of that. So we're going to go negative 395 thousandths divided by 2. Okay, and that should give us the proper depth to make the chamfer on this hole. It will also center drill enough that you'll still have a center point left for the 1/4 inch drill bit that goes into this. And it's possible we might actually be adding a slight chamfer to the edge on that hole as well, but that's not that critical. Okay, so we're going to go on to the next, and we're doing a drilling. It's just going to wrap it out. That's good. This is the spot drill. And we'll go ahead and accept that routine. Okay, the next step is we're going to drill the 1/4 inch hole. Okay, so that's the letter E drill. So go to drilling, drill. We're going to select from our library We're looking for the letter E drill. Okay, and then again we're going to go down to 2000 RPM because we're cutting steel. We'll leave it at 13 inches a minute. It's fine. We're going to select the entire whole series. So we're going to get the chamfer. We're going to get the outside cylinder. We're going to get the cylinder of the 1/4 inch hole. And then we actually want to get the counterbore on the opposite side. In steel, a 4-flute end mill that we're going to use doesn't cut right on the center of the cutter very well, if at all. So we want to make sure that our drill bit goes all the way through so that when we machine from the other side, we have basically a pilot hole in the center to start with for our end mill. Okay, and we're going to auto merge those so it's all one drilling cycle. And then we're going to go to heights. We're going to leave the top two at default. And we're going from the top of the hole to the bottom of the hole, and we're going to have the tip go through, and we're going to go a little bit deeper. So we're going to go 0.01, 10,000ths deeper, just to make sure we go all the way through. Alright, so we got our 1/4 inch hole. Moving on. Now we're going to, that we've drilled that hole, we're going to do 2 routines to make the counterbore. The first routine is going to rough the counterbore, and then we want a separate routine that's going to do the finish cut. And here's the reason. This is a very precise size on our drawing, and it's for a press fit bearing. So we want to be able to separate out the code just for the operation that does the finish cut. So if we need to rerun just that portion of the program, it's separate, and we can either post it off or we can start the program at that point. And that'll allow us to do cutter compensation to slowly take a little bit more off and adjust that cutter on the machine. So we're going to go to 2D milling, and we're going to select pocket. Okay, and a pocket it's going to take the volume and remove all the material. We're going to go to our library, and we're going to select our 4-flute 1/4 inch end mill, because those 4-flute is used for harder materials. We're going to slow the RPM down to 2500 because we're cutting steel. Our feed rate is going to be 15 inches a minute. Just go 10 inches a minute. Across the board. Now typically my plunge rate, I'll actually cut that in half. So let's put that at 5 inches a minute. And our ramp will do 5 inches a minute in case we are doing a ramp. Okay. Now we're going to go to our geometry and profile the bottom of the counterbore. Go to our heights. We're going to leave the tops at default. We're going to stock from stock top. We're going to go to the contour we selected. That's fine. We're going to the next tab. Stock to leave. We're going to leave a little bit of stock. 20,000ths is fine. And we're going to leave 0 in height. We don't care so much about the height. Okay. We're going to select smoothing because we're doing a circle. We want the tolerance on the code to be pretty good. And we're looking at our tolerance there is fine. Our passes. This is a horizontal pass. Right now it's set at almost the diameter of the cutter. You never want to go more than 80% of the diameter of the cutter, and in steel, probably less. So what we're going to do is we're going to decrease that. So if we go 0.25 and we multiply that by 0.7, let's say it's 70% of the diameter, we're at 175 step. I actually think that's still pretty aggressive. So let's set that at 30,000 side steps. And we're going to select multiple depths. We don't want to take it all in one depth either. So let's set our depth the same, 0.03, 30,000ths at a time. And our finish pass at the bottom. Yeah, we'll go ahead and do a finish step down at the bottom, which is 5,000. We're going to do one finishing step at the bottom, and we're going to do multiple depths, 0.03. We'll use even step downs. And in this case, we're not going to do any extra finish passes, because we know we're going to come back and do another finish pass. We'll just do a finish pass on the base. Okay, we're going to go to the next tab. This is all has to do with how is it going to lead in. So we got a lead in of 25,000ths, 90 degrees. We've got a lead in. We're going to get rid of the vertical lead in Don't need that. It's going to be 0. And it's asking, how do we want to plunge? Do we want to come straight down? Do we want to ramp as a helix? So we're going to leave this as at default, but a helix is generally what you want, and that way the center of the cutter is never really cutting. Okay, so for this case, our 1/4" end mill, we've already drilled out most of the center, so I don't think we really need a helix. What we're going to do is we're going to do a plunge straight down. And that should plunge towards the center of the part. And it's going to start its plunge 100 thousandths above the workpiece. There we go. So if we were to look at our toolpath, we start in with it starts in the center and it arcs in, arcs out, and does our roughing profile. Alright, so we've done our pocket. Now let's do a contour. It's just going to go around the outside and take it to finished size because we've left material on the exterior. So we're going to go 2D contour. We're using the same end mill, same parameters. We're going to pick the same edge. We're going to go to heights, and we're going to leave these at default. We're going to go back to the contour, and it's going to be wear compensation. Here you can override what the finish pass does at 10 inches a minute. We're just going to leave that alone. We are going to repeat the finish pass. We want a spring pass. This is something that needs to be very, very precise. And we're not going to do any roughing passes. We've already done that with the roughing tool. Okay, we're not going to leave any stock to leave, and we're going to select the smoothing so we get a nice round circle. We're going to go to the last tab, and we're going to try leaving these at default and see how they work. Okay, we'll hit accept. Alright, so we have a ramp in, an arc in, and then we have a profile. Now I noticed something. I have my vertical lead in. I don't understand why they default to that. It breaks end mills, but HSM sure loves it. So we're going to get rid of the vertical arc end. Hit OK. There we go. So we're feeding in. We're doing two finish passes. It's going to repeat it 2 times, and that's going to clean that up to finish size. So this is the routine that we might want to run over and over and change the cutter compensation on the machine. So we're going to change the name of this to 2D finish contour. And what that's going to do is it'll put it in the notes. That's done. Now we're going to move on to a little more profiling. So the next step is we want to machine off the end here. Okay, so we're going to use the same end mill we're using now, but we're going to do another 2-axis milling contour. Okay, and we're going to select the bottom edge of this. Now you notice I selected an arc and it did a blue line straight across. So right now it's going to default that edge is going to stop where my selection is. So we're going to go to the next tab, and we're going to leave the first few tabs at default. Those are fine. And we're going from stock top, but we're not going to go to the contour. We're going to go to model bottom. And what that will do is our contour should keep cutting all the way down to this edge here. And then we want to go just slightly past. So we're going to go -0.01. Now we're going to set our steps for that. Okay, so we're going to set this for wear compensation. And then we're not going to do multiple finish passes, but and we're not going to repeat the finish passes. But we are going to go along here. We're going to do roughing passes. And we're going to do a roughing pass that is 0.03. And we're just going to do one roughing pass. We're going to do multiple depths on that. The depth is going to be also a 30-second. And we don't really need a finish pass on the bottom, so we're going to leave that at 0 for finish passes on the bottom. You could put it in as a spring pass. And then we're going to finish pass only at final depth. We're going to use even step overs. And then that's it. Okay, so we're going to go to the next tab. And we're going to leave this all at default. Down here we're going to put 0 for our vertical lead in because we don't need that. And we'll go ahead and hit OK and see if we get the results we want. Okay, so we have it arcing in and arcing out at the end with a lead in. And then at the bottom we do a finish cut that's all one cut. Now we may have an issue here. If we arc in and arc out using that as our profile, we may be arcing in and out before the edge of the material. So I'm going to suggest that we change these lead-ins, and you can see how they change. So instead of leading in an arc fashion, since we can come in from outside of the stock and move in, let's go to Edit. Okay, instead of coming in at 90 degrees, we're going to come in at 0, and we're not going to have a radius. So we're just going to have a linear lead-in of, right now it's 25 thousandths. Let's increase that to 100 thousandths. And then we'll leave our lead out the same. Hit accept. Alright, so we're leading in off the workpiece, leading out off the workpiece, stock. We have a rough cut, and then we have a finish cut here. Alright, so we're done with that.